Good morning, aspirant. So in the last class, we have seen three factors which basically affect number of ions or mobility of an electrolyte. And there are four factors which basically affect those number of ions or mobility, affect both number of ions or mobility. First three factors we have discussed, four factors we have left with, that is concentration. How concentration, makes a difference in conductance for strong electrolyte or weak electrolyte. First, let's see strong electrolyte. Next, we will see weak electrolyte. Okay. For strong electrolyte, if concentration decreases, listen to me very carefully. If concentration decreases, then alpha same, degree of dissociation will be same. That means number of ions will be same. Ions will be same. But mobility will be higher. Why mobility will be higher? Let's see very carefully. When initially it was a cation and it was an anion, and there were two, you know, electrodes. Uh, One thing. Hmm. Here I have done one mistake. I'm clarifying you. Na plus will move towards this, and Cl minus will move towards this. Okay, and you know this, right? Okay. Now here suppose negative electrode. Now Cl minus will move towards this, Na plus will move towards this. Okay. But there is one electrostatic force of attraction between them, isn't it? Now another case, consider it is very dilute solution. Dilute solution means cation and anion are far enough. Suppose cation is here, anion is here. So it is the case of dilute solution. Here negative, 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 positive, positive, positive. Now this interaction is less. So easily it can move. Easily it can move. There is no restriction from this opposite ion, right? So here concentration is higher, here concentration is lower. So lower concentration means less force of it attraction between cation and anion and more the mobility. So overall what will happen? Overall lambda m will increase, molar conductance will increase because number of ions same but mobility is increasing, isn't it? So it is the first case for strong electrolyte. Let's go to the second case, that is weak electrolyte. Now we know alpha equal to degree of dissociation equal to root over Ka by C. If HA, dissociation of HA we are considering H plus plus A minus, from here this equation comes alpha equal to root over Ka by C. Now if concentration decreases, alpha will be increasing. Alpha will be increasing means number of ions will be increasing. And we know with this dilution, what happens? Mobility also increasing. So overall, lambda m increment will be much more prominent than a strong electrolyte, right? So lambda m increment is much more prominent for weaker electrolyte than the stronger electrolyte. Okay. Now there are two very, very important graphs. Listen to me very, very carefully. Here, for strong electrolytes, there is a relation between concentration and mobility. The relation is lambda m equal to lambda 0 m minus b root c. C is concentration, B is called Kohlraasch constant. Okay. Lambda 0 m means conductivity at infinite dilution. That means if the solution is diluted infinitely. Okay. Infinite dilution. I will tell you what that infinite dilution means later on. Okay. Now, this is the graph. This is the equation. Then we can easily plot a graph between lambda m and constant and root c. The graph will be like this with negative slope. The graph nature of the graph will be like this. Okay. If we extrapolate this, then we can get lambda 0 m. Okay. Because slope is basically b, right? And intercept is lambda 0 m. Infinite dilution means we are diluting infinite. That means we are adding infinite amount of solvent or water, because practically it is not possible. That's why practically, because we can't plot like this, we can't feel this, because practically this zone you can't reach upon. But you can extrapolate this graph, and from this value of this graph you can get lambda 0 m. That means infinite dilution, conductance at infinite dilution. Okay. Now for weak electrolyte, this equation will be like this: lambda m versus root c. This graph will be this, like this. Okay. If there is one electrolyte with mono positive cation and mono negative anion, that means 1 unit of positive charge, 1 unit of negative charge. Its graph will be like this: 1 1. If bi negative, okay, or bi positive, that will be 1 2 or 2 1, and 2 2, kind of, suppose bi positive or bi negative, suppose MgO, magnesium oxide. Okay. So this type of graph, if I am telling you this thing because sometimes in exams it can become that compare the compare the conductance versus root C curve for these three electrolytes, these three weak electrolytes. So among weak electrolytes, more conductance will be of 1 1 system. Okay. I hope it's clear to you. Now, to explain the behavior of weak electrolytes, there are two rules or two laws which we are going to discuss in very much details. First one is Kohlrausch law of independent migration. Independent migration. To study the behavior of weak electrolyte, Kohlrausch law of independent migration. Second one is Oswald dilution law. Oswald dilution law. Oswald dilution law, basically, this equation is basically result of Oswald dilution law. Okay. I know you know this Oswald dilution law because it is now, class 11 chemistry. It is being given Oswald dilution law. So I am not going to teach this. Kohlrausch law I will teach you in a very much details. Now there are theoretical background for a strong electrolyte also, and that is very much important, and that's a part of higher studies, and that is Debye-Huckel-on-Sagar theory. Debye-Huckel-on-Sagar theory. We will be discussing in very much details about this Debye-Huckel-on-Sagar theory, Wien effect, Debye-Falkenhagen effect, and these things. Okay, these are very interesting things and very easy also. Okay, I will teach you. Don't worry. I hope it's clear to you up to this point, because it was the fourth point of factors affecting conductance, and these four factors are the factors which will ultimately affect the conductance by altering either number of ions or by altering mobility. I hope it's clear to you. Thank you so much.